Okay. This expression right here, according to our very first unit, this is a bedmass situation, isn't it? Right? I don't like to interrupt because it's so rude. I especially don't like to interrupt when I'm learning something new. I especially don't like to interrupt when I'm learning something new, especially because I'm going to lie to the teacher in a couple of days and tell him I know what I'm doing and then not know what I'm doing. That's the worst kind of lies. Okay? This is code for shut up when I am speaking. Okay? If you can learn this by yourself, Dale, which you haven't proven yet, then by all means continue to talk to TJ. But we're on the third unit and you've yet to prove that. So figure it out. I have already lost one student from this room that couldn't follow simple rules. Do you wish to be next? Okay, next week, on Monday, you're going to spend the week here. The first time I have to remind you not to, you are spending the rest of the week out there. Do you understand me? Yeah. You can go to a computer lab, you can watch the video, and you can sit there by yourself and do this math. Do I make myself clear? Yeah. Do I? Because we've had this conversation, I have a feeling of deja vu about it. It seems to me we have talked about this before. And you, again, lied to me and told me it was clear. Are you going to continue to lie to me? Good. This is a bedmass situation. According to your very first unit, what would you do now? You would do the brackets first. What are the brackets? 20 plus 4. So according to the bedmass, we would not touch the 5, and this would become 24. Yes? Excellent. Now, none of you can multiply that in your head, so you would get out your calculators and get what for an answer? 120, correct? All right. Now, you guys are also very smart young people. If I told you to draw this, then what would you draw down this side where we have a 5? How do we draw that? 5 little boxes. Are they colored or are they not? Why are they not colored? Because they're positive, yes? Now, according to this, how many would I need to draw across here? 20. Are we going to draw 20? Of course not. But it would mean that we were going to repeat this group of 5 how many times? 20 times. Yes? So what is 20 times 5? 100. Now, come over to here. What is this distance? No. 5. Because it's a rectangle, right? And how many times will I repeat that going that way? 5 times 4, which equals what? 20. Now, all of a sudden, you can do this in your head. Because you know 5 times 20 is 100, and you know 5 times 4 is 20. So you know that this diagram shows that 5 times 24 is the exact same thing as 5 times 20 plus 5 times 4, which must, because they're all equal, be the exact same thing as 5 times 20 plus 4. Does everybody understand this logic? If all of those things equal 120, which we just proved they do, didn't we? We used our calculator up here to prove this. We used this rectangle to prove this. And then, because this equals this, we already knew about that one. Everybody with me? Yeah. All right. This is what we call the distributive property. Please understand what it means. You have already seen it in exponents. This one, 3 times 4 is the same as 3 squared times 4 squared. The 2 goes to everything. You have already seen this, but I didn't give it the name. Now I am. Cool? All right. So this is how we do it when we draw. I have 2 times 4x. The only difference now is there's an x, right? So how would I draw that? I've shown you how to draw it. This is supposed to be clear. Oops, too big. This is supposed to be unshaded. 2 times 4x. So what do I do to draw that? I draw 4x. How many times? Twice, because that's what this means. So what's the answer? Can you count? 8x. Right? Of course. Now let's go down to this next one, and we're actually going to draw it. After this, we'll use the shortcut, but we're going to draw it the first time. What does this mean? Think in your head. This means I need 3 of the trinomial, right? This is just like what we did with Paul. I need 3 of these. So how many times do I need to draw it? 3 times. Now Dale has given us even another shortcut. Well, you need 3 of each thing in it, don't you? If I was going to draw 3 people, I would need to draw 3 heads, 6 arms, and 6 legs, wouldn't I? You're exactly right, Dale. That's exactly what that means. So, if we're going to draw this, is there any right order to draw it? Can I draw this whole trinomial 3 times? Yes. Could I draw just this term 3 times, and then this term, and then this term? Is it the same thing? Who's in charge of how you're going to draw that? You are. Do you need to ask me? Is this right? No. Do you need to ask your neighbor? No. Because all of you know how to draw something 3 times, right? So let's do it. You choose how to draw it. How did I choose how to draw it? I drew the whole trinomial 3 times, right? Is that allowed? Did any of you draw it piece by piece? Like, did you do all the 2b squareds first? Okay, so you did it different than me, didn't you, Cole? Because I drew the whole thing. What did you get for an answer? Well, you drew this, didn't you? You got 6 big guys, 6 bars, and 3 little guys. Did it matter how he did his math? No, because what's the answer? 6b squared. We use b, but x would be fine. Let's be honest. And then negative 6b's, and then positive 3. Nothing new, easy peasy, right? All right. Let's do these shortcut. What does this 3 mean is happening everywhere inside? I need 3 of each of them, don't I? How would I draw in our shortcut 4p? What's our shortcut to drawing? 4 and a p, right? How many times do I need to do that? Once? Thrice. Right? So how many p's is that? 4, 8, 12. 12p. Now, negative 3. 3 little guys. Colored in. How many times do I have to do that? 3 times. To get what? Negative 9 minus 9. Exactly what I see there. Easy peasy, isn't it? How do I draw this guy? I draw a big shaded in one, yeah? How many times? Twice. To get what? 2 big guys, right? What do I draw here? 1 bar, colored or not? Not. How many times do I got to draw them? Twice. What have I got? 2 bars, because I can count. How do I draw this guy? 3 little guys. How many times? Twice. Because it's a 2. How many have I got there? 6. So what's the answer? Negative 2s squared, positive 2s, plus 6. 3 and 3. Pretty easy, hey? Now I'm going to tell you guys, let you in on a little secret. Every time parent-teacher interviews come up, I start writing a bunch of this stuff on my boards. Look around. And your parents come in, and I say, that's what we're doing.
I've never looked back there actually at them.
And your parents go,
and then you explain it.
I couldn't do that. And I say, I know. That's how smart your kids are. So when you get mad at them for not being able to do their math, you come in. See if you can do it.
My dad said
And
my math doesn't make any sense.
most parents can't do it. What does that tell you about most people on the street? They couldn't do it either. So when you guys feel bad about math, because honestly, when I tell you it's easy, when we're in the room, you guys are all like, that's easy. I get it, right? A regular person on the street, most of them don't.
There's a video, a guy went around asking people random math questions, and like 3 people.
Now, we're going to stop there, and I'm not going to give you any homework. You have a nice weekend ahead of you. It was a 5-day week. It was tough. I will have your quiz marked for you.
Next week, following week,
How do I get wrong?
No, he's in goal.